we're going to talk about another characteristic of waves, and that is called superposition. Which leads to interference. If I have more than one wave in a medium at a given time, then every wave that is there affects the medium. So for example, I have here a wave. This is just a snapshot. So you can think of the red beads as the medium. The straws are the wave itself. And so this medium is being displaced. Part of it is up, displaced upwards, and part of it has valleys. This wave has a very specific wavelength. We can pull out a meter stick and measure it at a certain distance from peak to peak. And it has a certain amplitude as well. I'm going to slide in another wave. This wave happens to be identical to the one that's already there. Okay? It has the same amplitude and it has the same wavelength. So I'm going to slide it in, and I'm going to slide it in such that the peaks are lined up so that both of them have peaks at the same location. The overall result for the wave, since both of them have peaks at the same location, the overall result of this wave is that it doubles in the places that were peaks. The valleys are still low. The peaks are twice as big. Okay? So both waves affect the medium however they were going to affect the medium. The overall result of the medium itself is simply the sum of what both waves are doing. If I move this wave and put the peak of one wave lined up with the valley of another, this one still has its peak, but this one had its valley. So once you add the two together, we end up getting a straight line. The peak of one fills up the valley of the other. And that way we get pretty much a straight line.
Cancel each other out.
They cancel each other out, exactly right. Right, it would look as if the medium had no wave in it at all. This is called destructive interference. You can think of it as destroying each other. So destructive interference is when the two waves cancel. So that means their peaks, one peak has to be lining up with the other's valley. In the case where we had the peaks at the same place, where it was doubled, this would be considered perfect constructive interference, where the peaks lined up exactly together and the valleys lined up exactly together. And so we ended up with a wave that's twice as big. This perfect constructive interference and perfect destructive interference, the flat line, only occurs if the waves that are interfering are identical. They have to have exactly the same wavelength. The only way you can get double the amplitude is if they both have the same amplitude in the first place. Okay? If these waves meet up anywhere in between, so they don't have the same, their peaks and valleys are not lined up, we get something in between. We still get something that's a little bit bigger, but it's not twice as big now. Okay. The concept of superposition is simply the summation of the waves that are in there, resulting in an overall displacement of the medium. Okay. Interference, we're going to talk specifically about perfect constructive and destructive interference. So perfect constructive happens if the waves are identical. They have to have the same wavelength and same amplitude. You end up with twice the amplitude to work with. Again, also, destructive interference only occurs if they have exactly the same wavelength and exactly the same amplitude as well. Okay? You can't get this unless they're identical waves. Now, you can have superposition whether or not the waves are identical. For example, I have another wave. Its amplitude is obviously smaller, and its wavelength is smaller. It's not identical to the wave we already had there. Yet, if if we put them both in the same medium, we get superposition in that whatever the one wave does adds to what the second wave does. But we don't get the perfect constructive interference. We don't have double the amplitude anywhere. And there's no way to line these up to get perfect destructive interference, to get a nice flat line. They can't line up perfectly because they don't have the same wavelength. And the fact that they don't have the same amplitude, they also cannot cancel each other out perfectly. Okay? So perfect constructive and destructive interference requires identical waves. They have to have the same wavelength, which means they'll have the same frequency as well. And then they have to have the same amplitude. So basically what superposition tells us, the total displacement of our medium is simply the sum of the individual waves. Whatever displacement the individual waves create in the medium. So you add up all of their effects and they total the overall displacement of the medium itself. So we're going to talk about a few applications of interference. So where we do have identical waves and they can have perfect constructive interference, meaning the amplitude doubles, or they can have perfect destructive interference, meaning they cancel each other out.